Hello everyone, I hope that whenever you're watching this, you're having a good morning, afternoon. This is a video to help you fill out your Unit 1 study guide. If you are in an odd period, you have your unit exam on Wednesday, and if you're in an even period, you have your unit exam on Thursday, right before your fall break. So this video is going to help you fill out your study guide. The first page is a list of suggested study steps. I would not come to the exam without having completed all of these. They're all very key, important study steps to be able to do your absolute best on this exam that's coming up. So we're going to go through and fill out the vocabulary together. What we're going to do is just write it into your study guide. What I recommend is following along with this and then later on putting this information on flashcards so you can internalize it before your test. So the first term is a function, and a function is a relationship. Usually a relationship between two variables that we call x and y, or input and output. It's a relationship that assigns each input value to exactly one output value. So what exactly does this mean? Well, let's do our mathematical example to think about what this actually looks like, what it means. So normally we'll see some sort of table that's like f of x. Sometimes it also says x, y. And the important thing to do is to identify your input and your output. On the exam, your input is always going to be your x variable, and your output is either going to be y or f of x. So what does it mean to have a table that matches each input value to exactly one output value? Well, one way to think of this is if we graph whatever this function, we want it to pass the vertical line test. Let's think about in the table, what it means is to have your x value never repeat. So I have to have all unique or distinct x values. I cannot repeat x values. So it could look like 1, 2, 3, 4, 5, 6. Doesn't have to be in order, but the important thing is that my x values do not repeat, or my input values do not repeat. And then for my output values, I'm just going to choose some random numbers, 10, 20, 30, 40. Key point here, output values can repeat in a function. So I could do like 40, 40, 40. That's okay. So that's a good thing to have in your mathematical example, because this was a common mistake on the Quest. Output values can repeat in a function. The way that we talked about this in class is we thought about the input as time and the output as distance, which is a really common example. So we thought about, okay, does it make sense for our output values to repeat? Does it make sense for someone to be in the same place at different times? And we said, oh yeah, that does make sense. It just means they didn't move. But what doesn't make sense is when your input repeats, when your time repeats, because you can't be in two places at the same time. So you can go back and look. That's handout 1.1a, where you can find some other mathematical examples that you might want to put on your flashcard, but this is the key idea here. Input values don't repeat, output values can repeat to define a function. Okay, next two words, pretty straightforward. Increasing we talked about means a positive slope. We also call that a positive average rate of change. Same thing. Negative slope would be decreasing, or a negative AROC. So an example would be, let's draw a picture. An increasing function might look something like this. A decreasing function might look something like that. And just to be very specific, we talked a little bit about intervals here. So like if you say this is the x value of 1 and this is the x value of 5, we could just focus on this interval of the function. And we could say this function is increasing on the interval 1 to 5. Okay, so more about intervals. An interval is a word that came up this unit. It might come up on in one or two questions on your test. And the important thing to know about an interval is it's a part or a piece of a graph. And it's defined by x values. So it's from one x value to another. So in the example we just did, it's from the x value of 1 to the x value of 5. So we could also use an example of like from the x value of 0 to the x value of 10. Important thing to remember here is that this is an x value. This is also an x value. Sometimes we call the first x value A and the second x value B, which we'll do in a later problem. And on a graph, that would look like focusing on, say the graph looked like that. If we were looking at the interval 0 to 10, we'd find 0 and 10 on our x-axis, and then we'd only look at this interval, or this piece of the graph. That's going to become very important next unit. This unit was just kind of an introduction. Okay, so for the rest of the vocabulary terms, for the sake of length of this video, I'm going to skip average rate of change. You have a lot of notes about that to copy into here, and we're also going to do an example problem with that in a little bit, and we're going to go straight to linear function for the sake of not making this video super long. Okay, so a common kind of question I saw both on the reflection after the quest and then also people's work on the quest was the difference between defining something as a function, which as we just said, a function means each input value matches one output value, and defining something specifically as a linear function. So maybe a helpful diagram would be like, okay, there's this big idea of a function in math, which is a relationship between two variables, inputs and outputs. And then we have all these different types of functions. So we haven't touched on this very much. We've talked in this unit, because it's all about linear functions, we've talked a lot about linear functions, y equals mx plus b. But in your other math classes, you've been introduced to quadratic functions. Another example would be like log functions or exponential functions. So just remember, function is like this big idea, and then a linear function is a type of function. Okay, so linear function, we defined it as a function that has a constant average rate of change. So an example of what a linear function might look like In a graph, a linear function would look like a straight line with a constant slope. Again, the equation y equals mx plus b, which we'll talk more about in a second. In a table, again, let's do input, our output. Say this is 5, 10, 15, 20. So the key thing here is the rate of change in the table must be constant. What does that mean? That means here I'm adding 1. Here I'm adding 5. I'm adding 1 again. I'm adding 5 again. To get from here to here, I'm adding 1. To get from here to here, I'm adding 5. So the rate of change, how the table is changing, how the function is changing, is constant. I'm increasing my x by the same amount that I'm increasing my output, my y, by the same amount. When you graph something like this, it's going to end up looking like this straight linear function, straight line. All right, so this would be, and then this would be my constant average rate of change, which is my definition of a linear function. Okay, that is it for vocabulary. Let's move on to key concept number 1, function notation from a graph, table, and equation. Okay, this was actually a very highly performing learning target on the Quest. It was like a 98% average. I did see some feedback that people wanted specifically to go over the tables problems. So let's quickly do an example of a table. Zero, 0.5, 1, 1.5, 2. And then for output, or for y values, let's go -10, 0, 10, 20, 30. Okay, so the key thing to remember with function notation is this kind of diagram that I saw a lot of you including in your Quest corrections. Okay, so whatever goes inside of the parentheses is your input or your x value. Whatever the whole expression is equal to, what comes out on the other side is your output. Okay, so that doesn't really make much sense until we put it into practice in a problem. So let's do that. So if I asked you to use this table to evaluate f of 1, you say, okay, the number that's inside the parentheses, I know must be my input. And if I look up at my table, I know these x values are my inputs, and these f of x, y values are my outputs. Okay, so if 1 is my input, I'm going to go up to the table, and I'm going to look for 1. I'm going to look for where x is equal to 1, because that's my input value in there. And then I'm going to say, okay, when the input is 1, what is the output? What comes out on the other side? What is the whole expression equal to? And the answer is 10. We also saw a structure of a problem on their Quest in class where I would say, like, if f of a is equal to 30, what is a equal to? Okay, so this is the opposite problem because I'm given my output. I know that my output is 30, and I'm trying to go backwards and figure out, okay, if my output is 30, what could a possible input have been? Okay, so look up in my table, find my outputs, see where the output is equal to 30, and I can see the only value where the output is 30 corresponds to the input value of 2. So I know that A must equal 2. Okay, let's do a quick graph example. So this type of problem showed up on your quest. It will definitely show up on your final unit exam as well. Okay, so have some sort of function that looks like this, and you might be asked to evaluate, let's say, f of a. Okay, so same idea. Same exact idea as the table. My input, or my x value, is a. So same idea, instead of going to my table, I'm going to go to my graph and I'm going to say, okay, where is my input value, or my x value equal to a, which is right here. And then I can see that on my function, when x is equal to a, it's going to correspond to a certain y value, or a certain output value, and not perfect here, but the output value that it corresponds to is h. So kind of the question I asked myself in my head is, when x equals a, what does y equal? And that's what always helps me. When x is equal to a, travel up to the function, touch the function, and then travel over to your y-axis and say, okay, what does y equal? And here it's clear that when x is equal to a, it corresponds to the point where y is equal to h. Our output is h. Okay, the next page has 2 key concepts: average rate of change and writing equations of perpendicular and parallel lines. So for these 2 key concepts, I'm going to ask you to go back through your handouts, go back through your notes, find an example problem where we found average rate of change. Your practice quest is also a good way to look, as well as your real quest that you took. You have lots of problems that ask you to find average rate of change that you could write here. For key concept number 3, writing equations of perpendicular and parallel lines, today's launch question would be a perfect question to write down here, because it has both perpendicular and parallel lines in it. You can also feel free to go back through your notes from your substitute last week, or from class last Tuesday, and find an example problem for perpendicular and parallel lines. The reason I'm having you fill out these last 2 on your own is to practice that skill of actually going back and using all the work you did this unit, using your notes to find your own example problems, because that's a very important skill. And the rest of the study guide is all filled out for you. After this, there's some practice problems. Make sure to try all these practice problems. They're very, very similar to what will be on the exam. And again, it's all good to study vocabulary and examples, but when you're studying for a test, you want to make sure that you're actually doing problems to study. You want to always study with a pen or a pencil in your hand. All right, so next steps you can find on the first page of your study guide. I would move directly into finishing your quest corrections and then solving all these practice problems. You can also start with making flashcards from these vocabulary terms if you feel like That's how you learn best, is by starting with the vocabulary and the terms. All right. Thank you very much for your attention throughout this video. Best of luck studying, and good luck. Let me know if I can do anything. I will be after school every day except for Wednesday when we have our teacher meeting, but please don't hesitate to reach out before this exam. All right, good luck, guys.